I'm going to do with the 2x cubed and the negative 8x cubed is I'm going to go down these bullets here. Bullet 1, bullet 2, and bullet 3. I'm going to make sure I'm following those rules. And the fantasy of mine is that you'll be looking at these bullets so much, you're going to internalize it. It's going to be in your bloodstream. This is like second nature. Well, like you'll memorize it. First bullet, make sure you have like terms. Do we have like terms, Monroy?
Yeah.
Argument.
2x negative honor question.
So they're not like terms. You change your mind. That's cool. What is? Are those like terms? Argument. So when I say argument, give me a reason why you hold that position. They both have x. Okay. Paragon, are those like terms? Argument.
Because they both have x and then they both have a 3.
They both have x and raised to the third power. They're both x cubed. What about 2 and the negative? They're opposite signs. Hold it, Rosa. Thank you. Give me a second. Give me a second. What are these numbers called again from warm-up? From yesterday? The coefficients are different. So how can they be like terms? The coefficients are different. Are they still like terms? You sure? I like that. I hope you remember that for the rest of your life. Because life is an argument. Coefficients are different though. This is positive, negative coefficient. But like Baragan said, they both have x and they're both raised to the third power. Are they like terms? You say yeah. You change your mind.
Yes.
Now you're confusing me. Are they like terms?
No.
You keep confusing me even more. That's cool. Casetta, what do you think? Are these like terms? No. Hey, no, what do you think? Okay, she gave up. Forget this. The casas. Like terms or no? You say yeah. I say you guys, whoever said yes was right. Yesterday, check it out. Yesterday we defined like terms, and if you're asking her, so you'll look at the video later on. A few minutes. Okay, never mind. Look at like terms, the way we defined it. Terms with the same variable raised to the same power. It does not matter what the coefficients are. If you have the same variable raised to the same power, they're like terms. That was yesterday's learned lesson. So coming back over here, like Baragan said, same variable, same power, ready to rock and roll. Look at the first bullet, satisfied. Make sure you have like terms. They even put 4 exclamation points. We do have like terms. Second, then simply add or subtract coefficients. Coefficient here is 2, coefficient here is negative 8. Do it. What's 2 plus negative 8? Like I say, son, if you guys have trouble with negative and positive numbers, I'll send you to boot camp for a little bit to review that. 2 plus negative 8 is negative 6. I'm going to put it right here because I don't have any room over here on the side here. So negative 6. Now look at the last bullet where the skeleton's at. Do not add exponents. So it stays x to the third. So many students your age will look at, hey, I'm adding, so let me just add the exponents too. X to the third. No, no, 1,000 times no. This is it right here. So what do? We had an expression and we simplified the expression. It was a binomial and we simplified it to a monomial. Well, that was yesterday's vocab with a tree map. It was a binomial, look at 2 terms, and we simplified it to 1 term. All right, here we go. Next example in this box. What's up, Fender? Watch this one now. 2x to the third plus 2x to the fourth. 2x to the third plus 2x to the fourth. 2x to the third plus 2x to the fourth. Rico, are those like terms? Argument. Right, the exponents are different, not like terms. It's kind of like asking, this much. What kind of fruits are these? Apples, bananas, yeah. What's a good variable for apples? A. How many A's do you see? How many B's? So if I ask you, hey, what's 2A plus 3B? He's all F-bomb. F. No, you don't have to go there. It's just apples and bananas. Relax. 2 apples plus 3 bananas is what? Nice. I like that. 2 apples and 3 bananas make what? It's not a trick question, you guys. I'm sorry. Fruit bowl. I like it. So, 2 apples plus 3 bananas is the same situation as this. 2x to the third plus 2x to the fourth. They're different terms. They're different kind of terms. So, you can't simplify the expression. You just leave it that way. 2 apples plus 3 bananas is just 2 apples plus 3 bananas. If you put them in a bowl, it's still 2 apples and 3 bananas. If you slice them up and make a smoothie, it's still 2 apples and 3 bananas. So go ahead and put right here, unlike terms. We're done. There's nothing else to do. I don't know what to tell you. Get over it. You don't have to add them. Stop stressing out. Okay? Now, what about multiplying terms? Ghost. What about multiplying terms? I'm going to use my God and blue again. I'll use the same terms I used in the first example. Let's multiply. Well, I'll change that. Watch this. 2x to the third. Okay, I'm going to multiply that times. Watch this. Times negative 8x to the second. Franco, these like terms. Argument. Beautiful. Beautiful argument. Different exponents are not like terms. But look what the first bullet says, ladies and gents. You don't need like terms if you're multiplying. You only need like terms if you're adding. Okay, so that's first bullet's done. Second bullet, simplify by multiplying coefficients. Let's multiply the coefficients. Coefficient here is 2, coefficient here is negative 8. What's 2 times negative 8? Negative 16. Now look at the third bullet. Now you can ignore the skeleton. Look at the skeleton says add the exponents. So it'd be negative 16 x to the beautiful. Done. Again, we simplified a nasty looking expression into a monomial. It was still a monomial up here, but it was just nasty and it looks ugly. So we simplified it. We didn't solve for jack. We didn't solve for anything. Jimenez? We didn't solve the expression. We just simplified it. This expression became that expression. Simplified it. We're not, don't use the word solve right now. Jimenez, let me talk, man. Come on. Stay with me. Okay? I trust from the bottom of my heart that this clears some confusion up in some of your minds. Any questions so far? We're not going to segue into our last section of the notes now. Go ahead. Sure. Actually, you came late. You just catch up late. No. All right, here we go. Now this next section of the notes, you have options. You can either put this section of the notes in the back of the paper I passed out or in the step sheet of paper. It's up to you. You want to write the word distributive property. It'll be easy. Did somebody of you see this before? No problem. You meant it. None of my class, please. Thank you, sir. Distributive property.